Hi, this is the video in continuation of the yesterday's video on functions. We were discussing about the different kinds of functions. Now we are going to discuss the polynomial function. Y equal to f of x equal to a naught x power n, a1 x power n minus 1 and so on up to an is called a polynomial function of degree n. The highest power of x in the expression is n, that the degree of the polynomial is n. Here n is a whole number. It cannot be a fraction, it cannot be a negative number. So in each and every term the power of x must be a whole number. Then only this expression will be a polynomial. The highest power of x is called the degree of the polynomial. All the odd degree polynomials domain is set of all real numbers. That means the polynomial is defined for every real number. Odd degree polynomials will have both domain and range equal to all real numbers. But even degree polynomial, domain will be same, but range will differ according to the question. Remember, all odd degree polynomials will have both domain and range, the set of all real numbers. But even degree polynomials will have only domain as the set of real numbers, and the range will differ according to the question. Next is rational function. A function y equal to f of x is called a rational function if it is of the form g of x by h of x. So a rational function is the ratio of two polynomials. G of x and h of x are two polynomials, and the ratio of these two polynomials is a rational function. While finding the domain of this rational function, the denominator should not be equal to 0. Find out those values of x for which h of x is 0, then delete those numbers or real numbers from the set of all real numbers. The set of all x for which the denominator becomes 0, delete them from the set of real numbers. The remaining part of the set of real numbers is the domain of this function. The range, of course, will differ according to the question. Next is step function or greatest integer function. Step function or greatest integer function. Y equal to f of x equal to bracket x is called step function. We can understand this function easily through the graph of the function. 0 is here, 1 is here, 2, 3, etc. minus 1, minus 2, minus 3. When x lies between 0 and 1, including 0, excluding 1. When x lies between 0 and 1, including 0 and excluding 1, then integral part of x is 0. When x lies between 1 and 2, including 1, excluding 2, integral part of x is 1. So when x lies between 1 and 2, including 1, excluding 2, then the integral part of x is 1. That means y value is equal to 1. When x lies between 2 and 3, integral part of x is 2. When x lies between minus 1 and 0, including minus 1, excluding 0, integral part of x is minus 1. So it goes like this. Minus 1. Y value equal to minus 1. Y value equal to 0. Y value is plus 1. Y value is plus 2. You can say integral part of x is an integer. That means y values can be 0, 1, 2, 3, etc. or minus 1, minus 2, etc. So the range of the function is the set of all integers. But the function is defined for each and every real number. Therefore, domain is all real numbers. Domain is the set of all real numbers. But the range is only integers. Whenever we write bracket x, remember this bracket x is an integer. Can be 0, can be positive, can be negative. Bracket x is always an integer because the range of the function is the set of all integers. Now, why this function has been given the name step function? You can see from the graph of the function goes like this. You can feel that these are like staircases, steps. That's why this function is called step function. Next is fractional part of x. Y equal to f of x is equal to x minus integral part of x. This function is called fractional part of x. It is also denoted by fractional part of x. Now, we can easily understand from the graph of the function the range of the function is 0 to 1. Range is close to 0 to open 1. This is the range of integral part of x. When you subtract from any real number its integral part, you will always end up with a fraction between 0 and 1. For example, if x is 5.6, then integral part of x is 5. So x minus integral part of x is 5.6. X is 5.6, integral part of x is 5. So the difference between x and integral part of x is a fraction between 0 and 1. That's why it is like this. If x itself is an integer, then it will be 5 minus 5, 0. So whenever x is an integer, then you will have x minus integral part of x is always 0. Now, fractional part of x is a number always between 0 and 1, excluding 1, including 0. So the range is this one. But the function is defined for all real numbers. Therefore, you can see the graph of the function lies between y equal to 0 and y equal to 1. 1 is excluded from the graph. The domain of the function is all real numbers, but the range is only real numbers between 0 and 1, including 0, excluding 1. Next is square root function. Y equal to f of x equal to root x. Whenever under root we write a number, that number has to be either positive or 0. Otherwise, root x will not be a real number. We are discussing about the real functions only. For root x to be real, the expression or the number which comes under the square root should be either 0 or greater than 0. So root 0 is 0. So when x is 0, y is also 0. So origin is a point on the graph. And when x is positive number, say x is 1, root 1 is 1. When x is 4, root 4 is 2. So if you can draw the graph of the function, it will go like this. When x is a negative number, root of a negative number is not a real number. So the domain of the function does not contain negative numbers. So x must always be greater than or equal to 0. X can be 0 or any number greater than 0, so it can be up to infinity also. So the domain of the function is close to 0 to open infinity. And what is the range of the function? The function takes, or the graph of the function completely lies above x-axis. So y values are always positive. Y can also be 0 because origin is a point on the graph. So when x is 0, y is also 0. So the range is also here close to 0 to infinity. So for square root function, remember both domain and range are set of all positive real numbers including 0. So square root function does not accept negative numbers. Next is exponential function. Y equal to f of x equal to a to the power of x when a is greater than 1. The graph of this function goes like this. Suppose a is 2, you will have 2 power x. 2 power 1 is 2, 2 power 2 is 4, 2 power 4 is 16. Like that, when x is positive, 2 power x is also positive. When x is 0, 2 power 0 is 1. When x is negative, say minus 1, 2 power minus 1 is 1 by 2, minus 2 is 1 by 4, minus 3 is 2 power minus 3 is 1 by 8, like that. You can see here 2 power x is always a positive number. It cannot be negative. Whether x may be positive or negative or 0, x may be positive, may be 0, may be negative, but 2 power x always remains a positive quantity. Therefore, the curve lies above x-axis. That means y value, that is a power x, 2 power x value should always be a positive quantity. Can 2 power x take the value 0? No. 2 power x cannot take the value 0. If you keep on decreasing x value, minus 1, minus 2, minus 3, minus 4, like that, when x value is decreased like this, 2 power minus infinity is 0. When x approaches minus infinity, 2 power x approaches 0. It is approaching 0 only, but it is not going to be exactly 0. So, the domain of the function is all real numbers because x can accept positive, negative, 0 values. But the y values are above x-axis, so range is open 0 to infinity. Note this point, 0 is not included because a power x or 2 power x can never take the value 0. As x approaches minus infinity, 2 power x approaches 0 only, approaches 0 but not 0. Therefore, range is open 0 to infinity. Next is logarithmic function. Logarithmic function. Y equal to f of x equal to log x base a is called logarithmic function. The base of logarithmic function can be any number between 0 and 1, can be a number greater than 1. The base of the logarithmic function can be a number between 0 and 1, any number between 0 and 1, or a number greater than 1. But you cannot take the base of logarithm as 1, base of logarithm as 0, base of logarithmic function as a negative number. So the base of a logarithmic function cannot be negative, cannot be 0, cannot be 1, but it can be any number between 0 and 1 or any number greater than 1. So the graph of this function behaves differently for different a values. When a is greater than 1, when the base of the logarithmic function is greater than 1, logarithmic function is an increasing function. So the graph comes from here and it goes like this. As x values are increasing, y values are also increasing. As x increases, if y also increases, it is the nature of an increasing function. When x is a, then log x base a, log a base a equal to 1. When x is a, y is 1. Like that it will go. But log 0 is not defined. Log 1 in any base is 0. So when x is 1, y is 0. When x value is 1, y value is 0. Log 1 in any base is 0. So the curve passes through this one. So it is an increasing function like this. But when the base is between 0 and 1, it is a decreasing function and the graph comes like this. So the domain of the function is any real number from 0 to infinity. So domain of the function in both the cases, when the base is greater than 1 or the base is between 0 and 1, the domain is open 0 to infinity. So log 0 is minus infinity. Minus infinity is not a definite number. So logarithm of 0 is not defined. So when x is 0, log is not defined and there cannot exist any y value. So as x approaches 0, log value goes to minus infinity. So the values of y start from minus infinity and they go up to infinity. Therefore y values can be any number from minus infinity to plus infinity. Therefore range of the function is from minus infinity to plus infinity. So range is from minus infinity to plus infinity, but domain is always a positive real number. It cannot be 0 also. So under log function, if x is there or any quantity is there, that quantity cannot be 0, cannot be negative. So under logarithm, whatever quantity comes, that quantity has to be positive. With this we are ending this video explaining all the types of functions. Thank you.